Thank you for joining the Once Changing the World, India's first future tech meets sustainability podcast. I'm your host, Eddie Havel, and today I'm delighted and honored to have with me Rahul Kala, who is an associate professor at ABV Indian Institute of Information Technology and Management and was previously an assistant professor at the Indian Institute of Information Technology, Allahabad, and the Center for Intelligent Robotics. He's the author of 5 books and over 130 papers. He has authored books such as Autonomous Mobile Robots, Planning, Navigation and Simulation, On-Road Intelligent Vehicles, Motion Planning for Intelligent Transportation Systems. So Rahul, really appreciate you taking time and being part of the podcast. We'll divide this talk in 2 parts, robotics, then autonomous vehicle. Let's start with robotics. Which is the most capable robot built in India indigenously? And what are the key challenges in building a robot?
Firstly, thank you for inviting me. It's an absolute pleasure to be with you, Eddie. Now, it's interesting that you bring up a point about manufacturing of robots in India because usually in electronics, we don't build a lot of stuff, rather we import. So my works is, of course, from Adverb, which recently set up their manufacturing facility at Noida. It's a warehouse company. So what their robots do is within the warehouse, they go from one place all the way up to the other, carrying items and sorts of crazy stuff, so that the Indian warehouses can deliver items uh, easily, pretty early as one may like. The other favorite that I recently had is because I'm from Madhya Pradesh, so Swayat Robotics is doing some wonderful stuff at autonomous vehicles. So, I mean, yeah, they've shown an almost level 4 autonomy on the Indian road. So that's again a crazy story out for me. So there's a whole lot of stuff which is happening. Here we people concentrate more on the intelligent side of the robotics. So as you would say that in a computer, so India may not be the best country that really manufactures computers, but the Indian software export industry is the one that completely rules the world. And a similar thing is what I expect in robotics also to happen, that there's a growing field of robotics consultancy. Every top company that you see today is trying to set up a robotics R&D consultancy in India, and that's the way for India to go forward, to take its expertise from the IT software export industry to the robotics full stack software export industry. And of course, there are a whole lot of companies that are doing some wonderful work in the software space as well.
Completely understand that India is leading in the space of the software, not so much in the hardware space, and that's the reason I think most of the stuff, hardware which is imported from China and other countries. But I hope that there's a collaborative effort where we kind of enable and empower the startups in the space of hardware also, not necessarily just the software, because I think there's a right balance. Talking about this right balance, can you elaborate on this balance bit? This mechanical engineering as well as the software in building a robot.
That's a great question. So, and of course, not only in robotics, but the government of India is doing its best to get the hardware manufacturing capabilities in India as well. So recently, the Prime Minister's Semiconductor Initiative is one of the major steps that will have a huge impact. And of course, the sensing technology is something that various educational institutes are coming in India. So there's a whole lot of space that is making sure that our dependence on the other countries is reduced as much as possible. And if we have to be Atmanirbhar Bharat, definitely we need to manufacture our own robotics. There's no question about that. It's high time that we have realized and made in very progressive steps. But then the balance that you talk about between the hardware and the software aspects of it, that is very interesting right now, because a couple of years ago we were speaking about open standards and tools like the robot operating systems, so that you could buy in any hardware, interface it with any software, and still that works brilliantly as an open source stack with all open interfaces. And whenever one manufacturer is supplying you expensive, you just replace it with the other. Now, even after a decade of open standards, and even after a decade of the open interfaces, we really couldn't go that much. I mean, today, or if you are taking a computer system, you can take processor from Intel, maybe this from Samsung, and still assemble it up. It's not easy in robotics, because every sensor, with along with its capabilities, has a resolution factor, has a frequency factor, and that affects my algorithmics. So if it's a high precision, I'll do something. If it's a low precision, I'll do something else. And choice of algorithms and everything could also change. So I think, I mean, maintaining in the right balance between the hardware autonomy and the software is where these, I started talking about robotics consultancy, and why is it that important, given that the problems are standard, the challenges are standard. I think that's where a whole lot of stuff gets around, that how do you customize your solutions, which may be for a generic scenario to your own specific scenario, so that the end use case is the one that is solved. So the same autonomous mobile robot may not work in a airport that works in a warehouse, and the one that works in a airport will not be the one that will be working in hospitals. So those are the kind of customizations that you need to do. That makes that makes it challenging, that while the same computer system might work with all these scenarios, the same robot doesn't. And I think that's where we people come into play.
I just saw one of your tweets, which mentioned that you're building something for the Viksit Bharat program, and that you foresee a future where no human is needed for dirty jobs, and that specially abled are tech assisted, where driving is safe and solutions scale to the massive Indian numbers. Can you elaborate on this tweet, and what are the steps that we are taking towards making this future happen?
That's a wonderful question. So let's start over with the first aspect. So if you imagine a traditional Indian warehouse, so there would be people who would be lifting up stuff and moving things around. So as you rightly said, that recently I switched jobs and I had to employ those shifting, unshifting, where people are doing the same thing. Now, if that's your career, what people do not understand is that soon you will start having health problems. That the human back is not supposed to carry heavy load. That's how the humans are. We're not high capacity carrying animals. So if it's a day or two, it's okay. So if it's more than that, then it's a dirty job that better be done by a robot, which is assisted by the human. And that's a real need, because even though labor in India may be cheap, but we cannot push the laborers into doing dirty jobs and having long-term health issues. We're also talking about the specially abled with multiple complex disorders. So if you are a wheelchair user, so at our campuses also, I've seen that these people really struggle in the everyday navigation. So imagine you need to drive for a significant part of the day from one place to the other. So it's a huge toil. And that's again where we need both safe electronic wheelchairs, which doesn't let the user do something that could be harmful for himself or the other one, as well as it is partly automated. it's not a full-time job. And again, that goes on to say that the problem is challenging because in India, in both these sectors, we are talking about huge numbers. So the Indian warehouses are not for 100,000 people; they would be there for 1 billion people, and imagine the kind of orders that they would be getting. So our systems need to be scalable up to that level, as well as wheelchairs users which are around are dealing with people in heavy density areas, and when catching things like a metro or going to offices, people are walking at grave speeds. So you need to be able to predict what the people around are doing with the chaos of the Indian scenarios, both indoors and outdoors, and to be able to look at those specific Indian things. Now, driving is something that is inherently very dangerous in India. So both because most of the truck drivers are, heavily loaded with working hours. They don't usually take a lot of breaks in between, as well as that they have to deal with the chaos of the Indian traffic. They may be vulnerable road users, which in India includes the cows, the dogs, and the street animals, to toddlers, which are just going around, to all the special vehicles that we have, the auto rickshaws, the e-rickshaws, and all those stuff. There's no lane driving. So there's constant overtaking, there's constant honking. So most of the safety systems using ultrasonics, using radars for cut-ins, they will not work in India because essentially in India, the vehicles are essentially kissing each other for a good part of driving, and that's a safety alert system. But in India, that doesn't work. So you cannot deploy those kinds of systems. So the problem comes back to us that India is unique. So we are unique in every problem. We do things very differently. Our numbers are very different. Everybody's interested in the unique kind of things that we have in our traffic elements, in our indoor vehicles. I mean, in a city like Delhi, you go to Chalk, so none of the metro stations at New York would be closer to that, both in terms of the volume of traffic as well as the density, as well as the constant rush between the people. So we are blessed to have endless problems, and endless problems give rise to endless possibilities of innovation. Or to say it in the other words, for every problem that's there outside, getting the solutions to India and adding the Indian spices to it. So that's what we did with culinary. We added the Indian spices to adapt it. Nobody would have done it otherwise. So adding the Indian spices to the algorithms creates a pool of need, and it creates possibilities where too many startups could innovate. And once all this happens, once we see technology in the hands of everyone, that is when we'll say that yes, it's a Viksit Bharat, when all our safety problems are solved, all our dirty labor problems are solved, as well as all our things which should not be done by the humans are being done by humans, that gets solved. So the technology of the West cannot be incorporated as it is. It needs to be Indianized. And I think that is where we are envisioning a lot of startups, a lot of employment, a lot of support from the ecosystem partners, which leads to a Viksit Bharat.
Rahul, yeah, more power to you and your vision that you have. I think, yes, there is so many problems, but you rightfully pointed out all of those problems give nothing but opportunities, opportunities to solve a problem, create an innovation, move forward, and like you also rightfully pointed out, the West is doing all the work when it comes about building these hardcore, hardware or, the software. But I think it's about time the rest of the world, including India, stands up and plays a part, because the only way where we will reach in democratization of this tech where it's truly global. And I'm glad that there are people in India such as yourself, creating or working towards that vision, towards possibly bringing in exoskeleton, for finding a way to solve the autonomous driving problem here in India. Because if we manage to solve it here in India with or chaotic roads, I'm sure it'll work anywhere. So your book, Autonomous Mobile Robots, Planning, Navigation, Simulation. Unfortunately, we are nowhere close to anything which is autonomous at this point in time. Yes, there are people working towards it. Could you elaborate on these autonomous robots? When do you think we would have autonomous robots? And maybe also elaborate on or give a brief overview on the books.
I think I'll start with the book first of all, and then come to the autonomous mobile robots. I mean, I keep talking about the Indian spices everywhere. So everything in India, we like to spice it up with our own flavors. So even this book is, apart from the technical jargon of equations and mathematics, has nice storytelling and stuff like that. So yeah, I mean, like everything that I do, this is Indianized. But coming up all to I mean, so what the book does is that it tells you step by step, right from raw sensors and actuators at the hardware stack, sometimes referred to as this thing, the DIY robotics, the do-it-yourself robotics, to all the latest things which are happening, which is how, I mean, things like the Tesla is working using advanced learning algorithms, to all the high-tech research which is being done both at autonomous mobile robotics level to the level of the manipulator. So that's why it's an extremely heavy text of over 1,000 pages. It takes you through a very nice journey from the hardware to the basic software stack, where we talk about how does a robot perceive the world, how does it know where is it in the world, how does it gather information with time, how does it represent the information with time, how does it do low level decision making, how does it do high level decision making. And then, because I love programming, there's a lot of elements of programming out there. So a lot of people don't know that to start robotics, you don't really need a heavy budget, because you've got extremely powerful simulators which are already there in open source market, and there's a huge open source community. So like a lot of people in machine learning just use Kaggle data sets, Kaggle contests, and do all the whole lot of stuff over there. So ROS has a very good community where you could just start over with simulation, building great algorithms, and putting the videos around, and tagging people like you to get invites like a a whole lot of stuff that you could do. That's what the book also tells you about, all the programming aspects and how you can use simulators to convert any crazy idea into a robot that you can see working in the simulation framework without having to spend a single penny. So I mean, yeah, like my labs are usually very hyperactive, where people are moving robots and they are like, okay, this looks so cool. So the book talks about it. But coming to the other part of the question, the more serious one about robotics now, I don't agree that the robots are not already there. The autonomous mobile robots are not already there in the market. So we talked about warehouses where, I mean, all the Indian warehouses also has robots, and not only the likes of Amazon. So they are already there. So the entire manufacturing is being done by robots. They are already there. A lot of agricultural sector are already using autonomous mobile robots. So they are already there. Even if you want to order it from your home, you can actually order from the manufacturer, any manufacturer, a robot. It will come and it has the capability of autonomously operating from one point to the other. That's all which is already there. You can do it. There have been endless demonstrations, including the ones by us, that it's a capability already there. But why do we see deployed robots into the structured and semi-structured environments like agriculture, like defense, like manufacturing, like warehouses, and not in personal spaces where humans are there, like airports, like hospitals, like offices, like if I have to send a letter to you, why do I need to call a peon to take the letter to our dispatch section? Why cannot the robot do it? Now, there's a reason that there are problems where you need to solve the problem 100%, and the little errors that you see are not acceptable enough. So driving is one of them. So even the people who incur accidents lose their driving license. They are only wrong 0.001% of the time, but that's good enough to cause something fatal. Mobile robots is exactly the same problem. So currently, what happens is that many times when we deploy robots using even a standard navigation stack, the robot would see a human and the robot would take a left nicely to avoid the human. But then what happens is that the robot fails to understand that looking at where the human is going, looking at where the human is seeing, the person itself will walk in the same direction. So the robot ends up creating an obstruction for the humans, and it's a very weird situation. And the person needs to now cooperate with the robot. Now, this is an interaction between one person and one robot. Imagine doing it with 50 people and a robot. Every interaction is something that the people would try not to have the robot. It makes the people feel unsafe. It makes the people feel odd. So, I mean, it sometimes happens with humans as well. So, you see a girl with on a mobile phone walking straight, you give space, but then the girl was trying to walk somewhere else and everybody's looking around you. So, the courtesy wasn't really needed. Sometimes it's okay, but we cannot have too much of it. Now, there are factors that robots will never be able to solve, like when two humans walk, using our eye gestures and body language, we communicate what is the right of way. And that's very specific to humans that without saying anything, we can communicate quite a lot. The human eye is a mysterious object. The human face is mysterious in how it communicates without uttering a word. But then there are things which the robot should understand. And those weird, atypical interaction, what we call as behaviors, is the one that we are now specifically working at. It's a very hard problem because we try to write down rules ourselves that, okay, these are the weird things which can happen. Let's write down rules. The rule base is over 1,500 lines of code and still incomplete. So it said it's hard to decipher what a woman wants. And I mean, the book on that would be too thick, but then it's same with man as well. So in short, what do people want to do, where they want to go is something very hard. Now, of course, we use learning-based solutions to solve exactly the same problem, and a lot of people are claiming that they can solve this problem of atypical, unsafe interaction with the human, trying to understand what the human is doing. But then we have been claiming that number one, again, the problem is of extremely rare behaviors, rare interactions, and it's always very difficult to say that you've covered it all. So these are things that only happen 0.01% of the time, which in my earlier example was causing accidents. So we can never be sure that we have covered it all. Now, here is again where Indianization comes into play. So we are not considering those tight spaces. We are not considering those women who are running on a discount and they want to get inside the shop. We are not imagining those toddlers who have been let loose and they want to go to a toy shop really fast as possible. We're not imagining big gang of 6, 7 college students who are there. We are not imagining those narrow spaces in our workspaces. We are not imagining furniture or old furniture or dumped items just kept out of somewhere. So there are things which are very odd to in India, and we will need to make robot understand all that and work in those rare situations as well. So can you buy a robot today and deploy it 100%? Yes. But will it be able to handle the chaos of the Indian human specifically? No. Now there's a second problem as well, and we acknowledge that pretty less. Only our group has lately started acknowledging that. Now you want robots for your homes, offices, buildings, malls, restaurants, each and every places, and you want them to really understand humans and be that sophisticated. But if the robot costs 35 lakhs, would anybody invest on it? No. I mean, for this thing, keeping a watch at your home, would you buy in a 35 lakh robot? I mean, it's extremely unlikely. So just Tata Nano came in for a segment of the market, and it said that, okay, let's convert everything to people who can drive, just like e-rickshaw came into a segment of the market, and they say that, okay, you don't need to be rich in order to commute. So those were local Indian problems. So the cost factor is now that we consider is another interesting Indian problem that I need to do the same high-tech solution, but I need to provide it at a low cost. The manufacturing will control one element of it. When India starts manufacturing the sensors, the motors, and starts its own fabrication, the cost will come down. But then the software also needs to match up. So I cannot assume that high definition 3D LiDARs are going to drive the Indian robots. So they're not going to get accepted. So for the cost factor, so I need to understand, I need to provide solutions at a much lower cost. And then that is good about the Indian scenario that when the people really see a use case, they start cooperating. And once you start cooperating with the robots, then a huge amount of possibilities to exist that you can still have the robots doing the stuff. Limbs, I think we just operation of the human. So in cases where the use case is extremely urgent, it's the next 3 to 4 years. But same as autonomous driving, in the low cost, high density, atypical behaviors, chaotic behaviors, unstructuredness of the Indian market, I think it's the low cost solutions are in another 10 years
Right.
now. And after 10 years, when they start making it, it'll go crazy because India, because of its scale, is a crazy market. So once we start adopting technologies, then we really adopt technology equivalent to the rest of the world combined. So that's
Right.
going to be a crazy period.
Yes, I mean, I definitely hear you that in a narrow space, structured environment, it works well. But yeah, if it's an unstructured space, then there are lots of problem that still needs to be sorted, right from vision to perception to motion to planning to intelligence and so on and so forth. I was seeing this demo of Figure One, because people around the world, researchers, companies are working on building generally aware robots. Now, Figure One has partnered with OpenAI, and they are leveraging their large language tool, the ChatGPT 4, and for speech reasoning. And I think it did a very fantastic job, the demo. It can understand the world, which allows it to reason and solve simple questions, based on its, immediate environment. Uh, can you discuss on any recent developments or breakthroughs in the field of vision, perception, motion, planning, or cognition, for which you possibly are saying that in the next 10 years we will have generally aware agents?
Okay, that's a complicated one. So, yeah, what are the advancements? What are people doing? And how could we, I mean, leverage and the general intelligence on top of it, many things. Now, I mean, firstly, of course, The major problem is we used to call it motion planning. Then that problem became the learning based motion planning or the learning from demonstration or the reinforcement learning. So, all kinds of machine learning, which is an obvious things because learning solves problem that cannot be solved by physics. And so all the learning from demonstration, imitation learning, long time back, a lot of work. People started using a lot of semantics to get extra information. So that form learning would be difficult to understand. Then people started to say that it's important when to learn, like you need to solve 2 plus 2. You don't need a learning based solution. So the machine decides whether to go with simple physics based navigation or to go with a learning based solution. Because with learning, you always have a problem that you might get a situation that the machine has not learned on. So even Deep Tesla would ask the human to take control. That became a very interesting problem. Now people are talking about integration of the LLM. So all the large language models are getting into the same learning space. So a lot, little work started by us as well. So what we are trying to say is that can whatever the robot needs to do be embedded as a text and given as an action command to the robot, and then that text also can be predicted by the machine learning system as well. In robotics, not a huge amount of research except for some very scattered, very specific use cases where it has worked, including it has worked for us. So a whole lot of stuff which is happening. Something that we will soon be talking about is what is our area of expertise, what's my area of work as well, and how to integrate humans at different levels. So, right from the level of training where the human provides some samples, test cases that the machine might get it wrong and not able to cover up, and to give that into high priority areas, or to use humans in the reinforcement learning as well, where the agent is by randomly acting in the world, but then you see the robot struggling. Like humans learn from interacting in the world. You don't teach a kid how to walk. The kid learns how to walk by interacting in the world itself. But sometimes you pick up the child and you tell the child what to do if the child is not able to do it. So doing all those kinds of things to reinforcement learning using human feedback. So the human is evaluating the system because reinforcement learning practically gets too complicated once you have a generic reward function. So yeah, some crazy stuff which is happening around over here. And now what we are slowly trying to say that I talked about how humans interact with each other to coordinate. So can the humans also coordinate using a new body language, using gestures and anything to tell the robot what to do, or using language as large language model as well? So a lot of interesting stuff happening around over here. A lot of interesting stuff that we do into this thing. Like making sure that the atypical and the rare behaviors are very well handled, and especially the safety critical behaviors. So you've got a different driver who would probably drive in the hilly regions to somebody who would drive in the city to somebody who would drive a Formula One. So the situations and the considerations are very different. So we've got systems where one of the machine learning systems selects the driver, and then that driver is trained on specific stuff, and then that driver drives best according to the situation. So a whole lot of stuff about here. But then the general intelligence, according to me, is always something that is very defined in the domain of artificial intelligence and robotics. Now, let's remember that even when we start teaching the courses on artificial intelligence and introduction to artificial intelligence. So, a debate that we rarely encourage is what is real intelligence, what's a general intelligence, what's hard AI, what soft AI and stuff like that, because it needs to be defined in terms of the schools of philosophy. And in AI, we are usually that, see, I have a problem in hand, I need to solve it with the best possible ways. Now, a lot of stuff, towards this thing, the general intelligence. Now, you really need to take it with a cause of concern. You really need to take it with how is the definition going on. It's a media hype. Like there was a time when we were talking about Google inventing its own language for translation. The news did die off because people, I think, understood any vector in the latent space can be given any fancy name like a language, but then it's just a vector in the latent space. So, will the machines have the general intelligence? Or could they only answer some specific questions in some specific industries that they are read upon and solve? This thing, can they make a decision making for any general scenario that they might be put upon in the real life, or will they do it for some specific use cases for a certain type of problems? I think that's an open question, that how general is the general intelligence, and I think that will take years to answer that. Where are the places where humans are unbeatable, machines are able to beat that, and where are the places where the machines, because of their pattern recognition and skills, their skills to store huge amount of data sets as weights and latents and everything, they are better, and the humans may no longer be close to that. I think that's something that has now emerged and will take years to answer.
So autonomous vehicle. In the beginning of the conversation, you mentioned autonomous level 4. Could you like briefly define autonomous level 4 versus 5? I had interviewed the CEO of Swayat Robots in 2020. He's working on autonomous level 4. What are the challenges that still needs to be sorted in building autonomous level 4 vehicles?
Okay, firstly, about level 4 versus level 5. In level 4, you always assume that there's a human inside the car. The human is attentive, and if needed, the human will take charge. So the driving is still being done autonomously. It's not that the human is there, so it's not autonomous. It's just that the vehicle can request a response from the human, and the human can give some high level directions if needed, versus a 5, where we strictly say that there's no driving seat. There may not be a driver on board itself at the first place. So the vehicle is on its own in totality. In the most extreme cases, yes, it could be making a call to a call center, and some help may be recorded, but those would be something that's like the rarest of the rare cases. So for every developer currently, level 4 is a good term to use, because you can always say that this is the problems that I've solved, but I don't know what my universe is. I don't know what are all the problems. I don't know what are all the situations. So if my algorithms cannot solve it, there's always a co-companion human who's got. So just like a new recruit would typically be given teams, and if you cannot do, your senior can solve it. So the human is the big brother who's always there. The challenges of level 4 driving, especially in the Indian conditions, are extremely large. Now, the greatest problem in India is that there are no well-defined driving rules which are followed. Now, a lot of people talk about companies like Tesla, but then the students were making line-following robots right from start. So I mean, you have a line and then the robot would just walk over it or aside it. And I mean, the road, well structured, is just one line on the left and right. And using sensories, even these projects could stop in good time. Western countries, what they have done is now two unique things. Number one is that they have developed extraordinary vision capabilities. So, I mean, every information needed for decision making because of the perception already exists, and that's something which is extraordinary even at a very high rate. And the second one is related that they've driven in hundreds and thousands of miles, so that gives access to a huge amount of high quality data, and there are people who clean that data and stuff like that. So it has been really rigorously tested. In India, we have the problem that no longer is it that I need to drive straight on road and just lane change if necessary. I've got completely unstructured roads, and because of that, and people don't drive lanes. So that's one of the biggest problems. In India, the roads don't look the same. So the rural roads will be different, the highways will be different, the city roads will be different. They may or may not be lanes. The lanes may be misleading as well. So there's a whole lot of challenge out over there. Traffic has high heterogeneity and every vehicle behaves differently. So I cannot say there's a vehicle in front of me. What is the gap that I need to maintain? And that's a big challenge. In India, I cannot drive cautiously. That's a very well defined driving strategy, like a lot of autonomous vehicle companies says never overtake. I mean, only when the vehicles are there for many years will that overtaking capability come. Just don't overtake. In India, if you don't overtake, you are driving behind an e-rickshaw on let's say a Mercedes Benz, and that technology is worthless. So you cannot do only cautious driving in India. In fact, if you try to maintain too much of a distance from vehicles around, somebody will come in middle, and instead of going forward, you will end up going backward and creating a traffic hustle, of course. So the most risk that you can do in India is to try to drive in lanes in a city which doesn't drive in lanes, because the people are expecting you to do something and you're not doing it. And our numbers and density is humongously large. Now, all this creates testing also a way difficult a problem. Now, we are talking about general intelligence. So, a human, when driving a vehicle, when accidentally is pushed on the pavement, knows that you don't drive on the pavement, you need to get it outside the pavement, and the human will be able to do that. Even in muddy roads, the human will be able to visualize flat spaces and drive in between. Modern day robot would say, not in my training data. So we've seen robots do random stuff, and people are like, why is the robot going random? It doesn't make sense. And we are like, see, it's a learning-based solution. When there's no data, even random is the best answer possible. So, especially in India, there are many challenges, and it will take time to really get those vehicles into the Indian market, as well as getting the people's confidence into the Indian market. But yeah, I mean, in the Western world, level 4 autonomy, I do see it coming very soon. Once the small regulatory issues, once the small ethical AI issues, safety issues, and all those issues are sorted out. And after that, you'll see not only vehicles driving in certain parts, in certain traffic conditions, in certain cases only, you will see them driving in anywhere around the country. That's something that should happen pretty soon.
Looking forward for that. Looking really, really looking forward for that. Rahul, are there any researchers or companies you look up to in the sense who are building autonomous systems, maybe autonomous vehicles or autonomous robots? And what's the ecosystem support like? Are there any ongoing collaboration systems, partnerships between the academia, government, and industry?
So in terms of ecosystem, yes, and I do see it primarily as a problem of, this thing that is being constantly worked about. So firstly, it's a problem that will primarily be solved by startups, and there are too many startups which are operating around this arena. So I'm looking forward to it. So we talked about Adverb. That's probably the one of the largest growing robotics company in the world. So backed up by Reliance, that's doing amazing stuff. So looking forward to it. So too many startups in the humanoid sectors which are doing very good. In terms of autonomous driving, we talked about Swayat. There's Wash AI, which is doing some crazy stuff around out over there. Then, of course, this thing in terms of drones, we've got too many startups which are doing some crazy stuff. So that's a problem that will be solved primarily by the startups, and the government has provided a lot of support lately. So I belong to the Technology Innovation Hub as a scheme of IIT Delhi. It's called the iHub Foundation for Robotics, and they are always inviting startups to join their programs. So, of course, not to forget the art park at ISC Bangalore is doing some amazing stuff. Not to forget the Han at IT Hyderabad is doing some amazing stuff in this area as well. So there's a huge amount of support by all these players who are there to give funding support, who are there to give mentorship, who are there to solve all the hard problems. In terms of industries, I think without exception, all electronics companies are now slowly getting into robotics. So Wipro is already with Pari in India, which is again has been doing great stuff. So high-tech robotics is doing some crazy stuff, especially in the autonomous mobile, in the autonomous vehicle sector as well. So a lot of our kids are at LG Robotics, which is again doing some great stuff. Sony and Honda have amazing robotics programs. So I think even the private companies are working very well to support both the local to support both the startups at one end as well as to have their own projects at the other end. So robotics is like a place which is under the watch of nearly everyone. Of course, when Google takes a lot of robotics initiatives, that's what you expect, that every company will bounce onto it. So yeah, I do look forward to this space. It's going to be a very interesting space, and a lot of things are going to happen, especially in India. And I think India somehow got lagged behind in the technology domain in times in the past, right from manufacturing at one time to probably getting into all the high-tech software, all the AI, all the LLMs. I think we just lag behind. Robotics is one place where we might even lead with all these startups doing an fab job. So yeah, really looking upon onto the space.
Right, exciting times. Rahul, my last question to you. You spoke about this ecosystem for your entrepreneurs. How is India's education system preparing for the futures? Because there are a lot of technology convergence as what's happening. With AI is converging with metaverse converging with Web 3.0, robotics, and so on and so forth. How is India's ecosystem, as in the education system, preparing students for careers in robotics and autonomous systems? And while you are at it, maybe you could also possibly paint a picture of how India is going to look like in the next 10 years, when robotics and autonomous vehicles evolve.
I think a whole lot of educational institutes have now robotics in some way or the other. So I belong to IIITM Gwalior, as the introduction said, and at IIITM Gwalior, they have two dedicated courses that run in robotics. So we've got one at the even semester and one at the odd semester. So and that prepares them quite a lot for robotics. And we have got heavily intensive AI and the machine learning programs as well that make sure that the students have a background. Uh, the students do some crazy projects out over here as well. So there are too many student projects which are there at different levels of robotics, right from perception at one end to the embedded electronics at the other end to control at the third end. And with me coming up now, I fill up the gap for the motion planning at the other end. So the education industry is now slowly starting to take robotics very seriously. We have a little problem of the absence of manpower because even we try to recruit a lot of people into robotics and we don't get a lot of faculty applications. So through your channel, I can also make a little bit of an advertisement that yes, we are badly looking at faculty in this area, and unless and until we get a lot of numbers, we'll not be able to change the future of the country to make a mammoth of a change. And of course, apart from IIM Gwalior, so I mean, IIIT Hyderabad has an excellent robotics program. IT Kanpur conducts a great robotics program, and so on and so forth. So the education industry has started doing well. I am into the contact with the other players as well. So they are all slowly starting the robotics programs. Like VIT Bhopal has an excellent robotics program happening. Of course, the other VIT at Chennai is doing great. Manavachna has an excellent robotics program which is coming up. So the UGC AICT approved colleges are only starting to get into robotics very nicely. So the student projects at robotics are getting sophisticated day by day. So the Delhi Robotics League that the IHA Foundation for Robotics IT Delhi does, it has some great entries and people are doing some crazy stuff around over there as well. So it's a whole lot of interesting, crazy stuff which is happening around over within the country to make sure that the people are industry ready and they are all the industries that are solving great problem. Now, my appeal would still be that we need a huge research infrastructure both in terms of the industries investing for capital support to the educational industry, which currently is not happening, the industry providing manpower training into the academic campuses for research and development, which currently is not really happening. So in India, the educational institutes and industries are still a little disconnect, and that there's a way to, I mean, bridge that gap. And we need a lot of heavy R&D into robotics in India at the first place. Now, IIIT Gwalior, we just have four faculty who work into robotics, and the numbers are much smaller than what we would expect. So yeah, in order to create the next working force, who are specialized into R&D for applying robotics into core R&D Indian problems. We need much more than that, and it cannot happen when the academia and industries works remotely. So I think there's a severe need for the joint initiatives in that direction. Uh, we have the R&D knowledge, we have the scientific expertise, we have the research expertise. I think the industry has some brave, I mean, some great use cases. So we ourselves were funded heavily by a startup called as Navajna Technologies, and then it exposed all the interesting Indian problems and all the challenges. So we got lucky that we got the support of Navajna Technologies, who were both happy to fund the research as well as provide manpower for it, as well as provide industry-specific use cases. But we need many such marriages between the industry and academia at one place. Now, the future, of course, is something that I like to foresee more than 10 years. So, what is the, I mean, what's it going to be in the next 25, 30 years? And that's more interesting for me. So, when we talk about the future, I think we are not seeing autonomous robots really operating in their own closed shell. I think we are seeing a lot of human robot collaboration, right from the vehicles, which may not only be on road, they may be off road, they may be aerial. In the outdoor sector, in the indoor sectors, we are not talking about a typical picture that we call as the autonomous mobile robots. We're seeing miniature robots for things like surveillance to huge robots for transport and carry. We are not only seeing the traditional manipulators, we are looking at whole sorts of manipulators, right from small ones that do miniature operations to the large one for heavy load lifting. We are seeing being filled by robots and in the company of robots at both industry, academic institution, offices, personal spaces, malls, hospitals, everywhere. Once that happens, the robots will become like co-workers whom you meet on a pretty much daily basis, and you work alongside them. And of course, the humans are the bosses. They have the right of way, they have the right of work. The robots, they do not cross humans, and those social norms get built. There's a new element which is being added into the society as we study it from a philosophical basis. And this new creature is not the one that's going to come in a single format that we people are used to, just a human. It's going to come in very diverse formats. And I think as humans, we should be both excited because it is bound to happen, as well as we need to start thinking about that as a society, where do we place these new creatures and how much do we cooperate from them? What do we require from them? What do they give us? And so on and so forth. So I see a very exciting future, which is extremely tech savvy, where we don't have to do any work just because we are super intelligent humans. The humans are for creative jobs. The humans are for unique jobs. The humans are not for repetitive, dirty jobs like transport of item, like picking up of item, like placing an item, like doing a regular driving of the car. So I think the future puts humans in their correct perspective right at the top of the creative head. And that's a future that I do look for.
Thank you, Rahul. Really, really appreciate you sharing that beautiful vision, the future. Normally, I think Hollywood has painted a picture of a dystopian future, when that technology kind of, becomes singular, when the singularity kind of happens, where machines become more intelligent than humans. But I guess, for for the longest time, we have used a tool to augment us. And like you rightfully pointed out, we're building a new species of sort, a silicon based species, which will be extremely diverse, which will be in diverse forms, and will be able to do a lot of things. We'll need to find a ways to coexist and leverage that tool to take humanity forward. And to do that, I think the core problem that needs to be sorted is, first, in India, find that partnership, that industry, academia, government partnership to achieve that future. So truly wish you the very best and hope that we go into the future. Into my listeners, if you like what you see in here, then please press the subscribe button. And until next time, see you guys. Bye bye. Thank you. Thank you, Rahul. Really appreciate this.